Hey guys, welcome back. Now we have a very good idea about the phases involved in MapReduce. Also, we have a very good conceptual understanding of what is a mapper, reducer, combiner, etc. Now to the fun part. Let's go ahead and write a MapReduce program in Java to calculate the maximum closing price by stock symbol from our stock dataset. Here is the game plan. We're going to write three programs: mapper, reducer, and driver program. We know what a mapper and a reducer is, but what is a driver program? So let's start with that. I have the project created in Eclipse already. So this project, maximum close price, is a Mavenized project. So I have all my dependency jars in pom.xml. So in the pom.xml, as you can see here, I have included all the needed Hadoop jars. So you can see all the Hadoop jars are included by Maven into your project. So you don't have to worry about the dependencies. This is a typical Java project, so there is nothing special about it. Okay. Open the source folder. I have two packages, com hirw max close price and com hirw max close price.test. So under the first package, I have three programs. One is the mapper, max close price mapper.java. The second one is the reducer, max close price reducer.java. And the third one is the driver program, which we are going to see now. All right, so let's open the program. Here you go. A driver program will bring all the needed information together to submit a MapReduce job. So what is the information you need to submit a MapReduce job? The first thing is, to submit any MapReduce job, you need to know the input location, that is the location of your input data set, the output location where the MapReduce job should output the result set. You should also provide the mapper that should be executed. You should also provide the reducer that needs to be executed, if there is any, right? So let's go one by one. Job object refers to a MapReduce job. Instantiate a new object and give a name to the job. When we run this job on a Hadoop cluster, we'll package the code into a jar, which we'll see in a bit, and Hadoop will distribute the jar across all nodes in the cluster. So Hadoop needs to know how to locate the jar file, right? So that's why we have the second line here, which is job.setJar by class. You give the class name, that is this class name max close price, as an argument to this method, and Hadoop uses this class to locate the jar file. In the next couple of lines, you will set the input path where you find the input data set and the output path where this job should write the output. So you will set the input path in the file input format class. There is a function add input path to give the location of the input path. So the first argument is the job itself, and the second argument is the location of your input path. So when you're running the program, you pass two arguments to the program, right? The first argument is going to be the location of the input data set, and the second argument is going to be the location of the output data set. The next step is to let your Hadoop job know what is the format of your input data set and the output data set, which you will do by setting the input format class and setting the output format class on the job object. So let's look at input format first. Input format is responsible for three main tasks. First, it validates the inputs, meaning make sure the dataset already exists in the location that you specify. Next, split up the input files into logical input splits, each of which, that is, each of the input split is then assigned to an individual mapper. Finally, and this is important, input format provides record reader implementation to extract input records from the logical input split for processing by the mapper. In our case, our stocks dataset is of text format, and each line in the dataset is a record. So we'll use the text input format class as the input format for this job. Hadoop provides several other input formats, and each designed for specific purpose. For example, if your data set has binary key value pairs, you can use sequence file input format. And there are several other important file formats that are in use today. like file formats for avro, sequence, RC file, etc. In fact, due to its importance, we have a separate chapter dedicated to file formats. Furthermore, we'll also look at implementing a custom file format in the later chapters. Similar to the input format, output format validate the output specification. Meaning, is the output directory specified already exist? If it already exists, it will throw you an error. Because when you run a MapReduce job, Hadoop doesn't want to by mistake overwrite the existing output directory or any other directory, right? So it's kind of a safety check. So the first check is validate the output specification, make sure that the directory that you specified for the output doesn't exist. So Hadoop can create it while generating the output. The next thing output format has is a record writer implementation that is to be used to write out the output files for the job. So input format has a record reader implementation, whereas the output format has the record writer implementation. Makes sense, right? One is to read and the other one is to write. Again, just like the input format, Hadoop comes with several output format implementation. In fact, for every input format, you can find a corresponding output format. And also you can write custom implementations of output format as well. So now we talked about input format and output format. Next, in the driver program, you have to specify the mapper class and the reducer class. So I've already returned the mapper, which is max close price mapper, and the reducer is max close price reducer. So I've specified what is my mapper and what is my reducer for this job on the job object using the method set mapper class for the mapper and set reducer class for the reducer. You also need to set the output key value types for both your mapper and reducer. The output key from your mapper and the output key from your reducer in this case or for this program is of type text. And the value in your key value pair, that is the output value from the mapper and from the reducer, is of type float writable. These types certainly look new, doesn't it? Yes, they are. There are writable wrappers in Hadoop for all major Java primitive types. For example, the writable implementation for int is int writable. For float is float writable. For boolean is boolean writable. And for string, it is text. But why new data types when we already have well-defined data types in Java? Writables are used whenever there is a need to transfer data between tasks. That is, when the data is given as input and output to and from mappers. Also, when the data is given as input and output to and from the reducers. As you know, Hadoop is a distributed computing framework, which means you will have mappers and reducers distributed in many different nodes. And this means you will have a lot of data being transferred between nodes. So when there is a need to transfer data over the network between the nodes, the object must be turned into a byte stream. And this process is known as serialization in Java. As you can imagine, Hadoop is designed to process millions and billions of records. So there is a need to transfer a lot of data over the network. And hence, serialization should be compact, fast, and effective. Make sense? But the authors of Hadoop felt that Java's out-of-the-box serialization was not that effective in terms of speed and size. Here are a couple of reasons why they felt so. You see, Java serialization writes the class name of each object which is being serialized to the byte stream. This is to know the object's type so that we will be able to deserialize the object from the byte stream later, right? So, and every subsequent instance of the class should have the reference to the first occurrence of the class name. So as you can see in the slide, we have three instances of employee object, employee 1, 2, and 3. And the first instance clearly has the name of the class. The second and the third instance refer to the same name. So it must have reference handle to the name. This reference results in two problems. The first one is the space, and hence it cannot be compact because it is adding more space. The second problem is that the reference handles introduce a problem during sorting records in a serialized stream. As you know, during the shuffle phase, the key value pairs are being sorted by key. So sorting is a key element in MapReduce. Since only the first record will have the class name, it must be given special care. So writables was introduced to make the serialization fast and compact. How? By simply not writing the class name to the stream. Then, if you don't write the class name to the stream, how would you know the type during deserialization? The assumption is that the client knows the type. So whoever is writing it will know what the type of the serialized object is. And this is usually true. And there is one more benefit of using writables as opposed to regular Java types as key value pairs. With standard Java types, when the objects are reconstructed from a byte stream during the deserialization process, a new instance for each object has to be created. Whereas with writables, the same object can be reused, which improves processing efficiency and speed. Later, we are going to look into how to write custom writables in a very interesting example. So if you logged into LinkedIn or Facebook, you would see like your common friends, right? So if you're looking at a friend's profile, you will see what are all the friends that you and your friend have in common. So we'll look into the common friends problem and how we can address that problem using MapReduce. When we do that, we'll talk about custom writables. Okay, moving on. Back to our driver class here. The job wait for completion method submits the job and also wait for it to finish. You can set the Boolean argument to true so that you can see the progress of the job on the console. So that's our driver program. Guys, let's pause right here. We'll continue our discussion in the next lesson where we'll look at the mapper program, the reducer program, and execute the MapReduce job in our cluster. Let's move on to the next lesson.